All right, so today we're going to talk about pointers and references. I hope everyone can see VS Code. Yeah, that should be fine. All right, so I've set something basic up, right? Like, what exactly is a pointer, right? So the basic concept of a pointer is that it's just a memory address, right? You know how everything in C++ is located at a location in memory, right? In every programming language, actually. So pointers just point to that memory, right? So I have a value 3 here, a given value 3, right? And I just say, okay, this pointer, yeah, you point to this value. So now modifying this pointer would mean that I modify this value. And I can illustrate that by changing the value in this function, right? So the syntax for pointers isn't very complicated, but I'll just explain it quickly. So you have an in pointer, which says, okay, you point to an integer. You're literally the location of an integer somewhere else in memory, right? And then you dereference it, and you say, okay, this is now equal to 5, right? So I give it the initial value of 3, and then this change value changes it to 5, right? And I can demonstrate that. Right. So you can now see that value is 5, right? I can step back. I'm sorry, this keyboard is very annoying, but basically you can see that the value is 3, right? And you see the value pointer is just 0x7 whatever, right? It's pointing to some address on the stack, right? We'll get to stack and heap later, like what exactly are they and how are they used and when. So we see this function, it says, okay, change value, right? And that's all it does. That's all that a pointer is. And really there's nothing more to it. The syntax can get a bit confusing when it's a constant pointer or a pointer to a constant value, but we'll get to that in a bit, right? So, okay, we see the value is 3, right? And now it's still 3, and this has finally been assigned, this value, right? So now it got its proper value, right? And now the value is 5, because this function says, okay, well, so you get a pointer, right? And then this says, okay, well, literally the value at that address, right? That is now 5, right? And then if you step over again, right? And I say, okay, now it's going to be 3 again, like, and it's back to 3, right? And then in this function next time again, you'll see that it'll change it to 5 again, right? You'll see value 3, pointer comes at 3, right? So it's the exact same thing, right? Any questions? How do you do X? Good question. You do it like this. Right, so actually I do want to repeat that, right? A pointer is a memory address of a variable, right? That's all it is. It's just a number, right? Like people make it too confusing and they'll go in like, yeah, it's some location in your RAM and it is very complicated semantics, but it's really just something that you can copy around, but it'll still like modify the original value. And yeah, I'll demonstrate it using an illustration later, right? So I can now say change value again, blah, 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 and it'll be back to 5 again. Right? Value 5, pointer contents 5. Right? Is that like understandable? Xornal++. Xornal PP. Right, so I would like to get more into depth about how exactly pointers work, right? And we'll illustrate this using the stack and the heap, right? Okay, I just moved Discord to my other screen so I can still see it. Okay, so right, so we have value, right? So what happens is we say, okay, value is 3, right? The content of value, which is literally just a variable, is 3. I prefer C++, but let's stay on topic. The value is 3, right? And then we say, okay, we have a pointer, and we say, okay, now this. Right, you're literally a pointer to value, right? They point to the exact same address, right? Like value is located somewhere, and then pointer says, okay, you're also there, and that's illustrated in this stack, right? For everyone that doesn't know what a stack is, it's just data, right? It just builds up from the bottom. How is an int 8 bytes on x64? It's not relevant anyway. Its value is 4 bytes, right? And then a pointer is 8 bytes, right? No. Just one. This block. One block is 4 bytes. Right. So you say, okay, this pointer points to this, and then if you modify whatever that pointer points to, that is the exact value. Yeah, it's. I know it's annoying. C++ cult. I know, right? All right. So people that watch this on YouTube later, you won't be able to see chat on Discord, so that kind of sucks. So when we switch to Twitch, it'll be better probably. Right. So how this looks in assembly is actually quite interesting. So we say, okay, int value is 3, right? So some location on the stack is now 3. So we say mov the base pointer minus 4. Your value is now 3, right? Like this is just 3 somewhere on this stack, and then we say, okay, we now have a pointer to this value, so we say mov RBP minus 8, which is just like 4 bytes after the int, right? You're now literally just the value RBP minus 4, right? So you can see like the actual address of this 3 is now this, right? And then if we say dereference that pointer, then we just say, okay, well, mov r this again, just that pointer again. I don't want to write it out again, right? That's all pointers is, and I hope that's clear to understand. I'll be using one illustration, right? So the way you can see memory, right, is just as one big line, right? It's just a street of houses basically, right? So I have a house here, and a house here, and a house here, and a house here, and then on the opposite side you'll have houses again, and then this house 1, 2, 3, 4, 5, 6, 7, right? And so on, right? And then a pointer is just his house number. Actually, you can. I've done that before. It works. But I just wanted to go in depth. If you didn't understand this, then ignore it. Right? Sorry for that if you didn't get it. But basically, the pointer is his number. And then when you dereference it, you get whatever is in the house. Right? I hope that's basically it. That's what a pointer is. That's all it is. People tend to overcomplicate it, but it's really not that complicated. Right? Any questions? No, we're not doing function pointers. Any other like direct pointer related question? Not yet. Not unique shared pointers yet. Don't care about DOS that maps that memory. This pointer, sure, we can do that. But there will be an episode, like a lecture from Yinsei, who will do data structures, which will go over the this pointer. It's not relevant what it is for now. That was it, then I'll move on to references. Pointers. Somebody tell him. Okay, so I guess we'll move on to references then. Yeah, I'll explain the syntax of const pointers. That's a very valid thing. Okay, so I have an in pointer, right? It might be easier if I switch to VS Code. Right, so we're back in VS Code, right? And the thing that a const pointer is, I'm not. Oh wait, let me restart it. How's that? Yeah, I can see it myself that it's active again. Okay. Right. So regular pointers are fairly easy, right? And the syntax for them really isn't that complicated. All you say is, okay, well, dereference it and get a pointer to it. Right? That's all it is. Yeah, we'll do that soon, dude. Chill. Right, so that's pointers, right? And then constant pointers have they're essentially the same thing, right? You can either have a pointer that you cannot change the address, what it points to, or you have a pointer that you cannot change the content of, right? So either I can change value or I can't change value pointer, right? Or both. Yeah, of course. Right? So say I don't want to modify the actual value. Like pointers are very easy as soon as you get them, right? Anything before the star applies to the value itself. Anything after the star applies to the pointer. Right. Right. This shouldn't compile. I'm not sure why it doesn't. Oh, wait, no, it does. Never mind. Wait, what? No, it shouldn't compile. Because you're saying, okay, this constant pointer, right? But it points to a value that can change. So let's change that. Right, so now we have a pointer to data that cannot be changed, right? It's very simple. Anything before the star applies to this type, right? Like to the int, right? And then everything after the star applies to the pointer itself, because keep in mind, a pointer is just an integer, right? And if you say, okay, you cannot change this integer, then so be it. The compiler will enforce it, right? So if you then say const int pointer const x, right? This means that that x will always point to value, right? It will always point to this specific value, right? And the reason I'm getting into this is because it's very important for understanding references, right? It's important to understand the concept of only being able to point to one value, right? Like one location, because that's exactly what a reference is. So we just made a switch to references, and I hope everybody gets pointers. If you don't get it, ask your questions, and I'll get to them later. Right. So we say, okay, well, x, right, is now a pointer to value, but that pointer cannot be mutated. I hope everybody gets that now, right? Remember, the pointer is the house number, and then the value is whatever is contained, right? I will just continue. So now we get a similar thing with references, right? And the syntax, I agree, the syntax for references and pointers is very confusing because they're combined basically, right? So both references and pointers use the ampersand, right? Right? This doesn't compile. This won't compile because this is not a value somewhere in memory, right? Is an actual literal value, which like as we said, a reference is exactly the same as this, right? Except for some minor difference, but we'll get into that later. So basically, I cannot assign this, but now I can say, well, int reference y is value, right? And that is completely fine. So we say, okay, well, int reference y is value. So y is now literally value, right? If I modify y, I modify value. And if I modify value, I modify y, right? Just like the pointer example that we had before. So I can say, okay, whatever. That's being weird, but let me just step. For some reason that doesn't work. You'll just have to take my word for it that why it changes. Let me try that again. It's not optimization, it was still running the previous binary. Okay, there we go, I think. Yeah, okay, there we go. Right, so we see, okay, value is 3, right? X is this pointer to this address, and then Y is that value. For some reason, it whatever. That was because of some undefined behavior stuff in C++. It doesn't matter. It's 3 now, right? It's exactly the same as value. And to demonstrate that when changing Y, value also changes. Let's set it to 6, right? And then you see, okay, both Y and value are 6. Right? And then back to 3, right? It's literally a pointer. It's this. What a reference is a pointer, but a reference is guaranteed to be valid, basically, unless you pull some reinterpret casting or whatever. A reference is guaranteed to be valid, to be pointing to something that it was valid at some point. It's not guaranteed to be valid forever, but at the time you create it, it's guaranteed to be valid. There is no such thing as a reference to 0, right? Because I can say, right, and then now this null pointer, right? This is 0, right? This is very frustrating. VS Code is very frustrating. Right, so null pointer is literally a pointer to 0, right? If I now dereference this, I do not own this memory, so it's invalid, right? So that is what references and pointers are. So the difference is that a reference cannot be reassigned, right? Because if you reassign it, you just change the value, right? You don't change what it actually references, right? Whereas this pointer, this one, is exactly the same, because I cannot reassign this one either, right? But it can point to 0, so I could assign it null pointer, and then it's just the same shit as like undefined behavior, basically, right? So that was pointers and references. Did everybody get that? Because we just covered 2 very big topics in 18 minutes. I'll wait a minute for everyone to type. Okay. So you see this, right? You see this null pointer, right? Null pointer is a pointer to address 0, right? Address 0 is not owned by you. It is a value that we all agreed on. I'll get to heap and stack later. This address 0 is something that we all agreed on. It's just a null pointer, right? It's just a pointer to something that's invalid, basically. So if you get a null pointer from somewhere, you should always check that. Because if you don't, then you get a thing that's called a segmentation fault on Linux. I can show you that, but I really don't feel like it. Yeah, that I think it's like 11 or something, like code 11, but whatever. Right? Oh shit, hi Wolf. Okay, 127 then. Same stuff. Right. Okay, yes, it is easier to use references, but pointers are older than references. That's one of the main reasons that we still have pointers. They're just so embedded into the language, and to maintain backwards compatibility with C and older C++ versions, they're just there. Right? They won't get removed anytime soon, so better get used to them if you want to do C++. Okay. Yeah, exactly. That's the main difference between pointers and references. Yeah, apart from that, they do the exact same thing, except the pointer is not guaranteed to always point to the same location, but a reference is. Like, as soon as a reference is initialized, it's done. If you want to make it point to something else, then reference something else, then you need to make a new reference. Okay, so far for pointers and references. It's depending on the situation, whether it's better to pass by reference or pointer. That's off topic, Tony. But basically, in this case, there's no difference. Right, we're not going to do template meta programming because that is something advanced, and we actually have another staff member that will dive into those. It's a really interesting topic. Yeah, guess who that is. But okay, right. I would like to get back to he's Pengu. Thero is not a staff member. Okay, I would like to get back to external PP. Let me switch Discord back as well. Can everybody see that? Yeah? Okay, great. Let me just erase what I previously did. And then we can get onto stack versus heap. Since I also got that question, I would like to get into that. Yeah, you can invalidate references. And I'll give an example later. I gave it before the stream because somebody had a question about it. But we'll get into that in a bit as well. Right, so stack and heap, right? So the thing you need to know is that the stack is something that the OS gives to you, right? Like the operating system gives you usually, right, between 2 megabytes and 8 megabytes worth of stack, right? And you just keep pushing onto that stack, right? So every time you add a value, so I say value 2 is 5, right? Then this is value 2. And then this would be value 3, value 4, value 5, value 6, right? And then depending on how big your data is, right? Because an integer is 4 bytes, like an int on x64, but a pointer is 8, for example. So it just pushes onto the stack, right? And then there is RBP, which is a CPU register, which just keeps track of where you are right now, right? That's all you need to know about RBP. It just keeps track of where your stack is filled up to at this point, right? Okay. So that is what the stack is, right? And we call this automatic storage duration. And it's called automatic storage duration because it essentially manages your stack for you. Yeah, it's a specific type of memory. Stack is a very specific type of memory, and we'll get into the other types soon. There's 3 other types. 2 are commonly used. Right, okay. So, because RSP then, my bad. RBP is the base pointer. Yeah, you're right. It's in the name, R base pointer. But yeah, you cannot store an 8 bytes pointer in a 4 byte integer. Okay, so I want to give a code example, right? And I'll just do it here, right? So these are curly brackets. I know my handwriting is shit, but it's fine. So I say, okay, and x is 5, right? So I have my stack here. It's curly because my tablet's a bit messed up. Right? Don't laugh at me. That's better. Okay, so I say int x is 5, right? And then it puts x here, right? And then I say int y is 7, right? I hope that's readable. Probably not. So y is there, right? Right. And then as soon as I get here, right, the compiler realizes like, okay, so this is the end of this block, right? After this, we're not going to allow you to use it anymore. So then compile time, it'll realize like, okay, well, these 2 aren't allowed to be used anymore. And then as soon as it reaches this, it just realizes, okay, these are free again, right? Somebody else can use this now. So if I then say int y is 9, then y gets placed here. Let's name it y2, right? That's what automatic memory management is, right? And this is something that's very convenient because it allows us to use a principle, but the principle of cleaning up after yourself, basically. But somebody else will get into that in some future lecture, right? Because we're approaching 30 minutes, I think. Right, so that's a stack, right? No, it wasn't is y. It was like is 2 or something. I don't know what I did. Did I say is y? I meant is 2. Because y doesn't exist there anymore. 7. Yeah, my handwriting is garbage. Sorry for that. Okay, so let me get rid of these. Okay, so now we have the heap, right? We get access to the heap by using the new keyword or malloc or whatever, right? It's not a keyword, it's an operator, by the way. But so you have the new operator, right? And what new does is it says, okay, well, I would like a new int, right? And then this tells the operating system, okay, well, go look for this many bytes on the heap, right? Which is this big chunk of memory that's just unmanaged. You can see it as unmanaged, right? So what it'll say is, okay, well, I found an empty 4 bytes here, right? Okay, so this is now 0. This is my int, okay? Because a default value for an int is 0, right? And then what you get from this is a pointer to this. And we still know what pointers is, right? Because a pointer is just location. It's a location of that integer, right? So we say, okay, well, int pointer data is new int, right? So here's something else, right? And then we say, okay, well, this is data, right? And then data points to here. The issue with heap allocation is that it doesn't, the name of heap allocation is dynamic storage duration, right? We also call it dynamic storage duration because, well, the duration is dynamic. It's not managed for you. You need to do that yourself, right? So what we get is that we say int data is new int, right? And when we're done with it, we say, okay, well, yeah, we'll do that in a bit. I actually already did that, but I didn't mention the name scope. Right, so we say, okay, delete data, right? And ideally, you'd want to do that at the end of the scope. So let's get our curly brackets again, right? Okay, we now say, okay, int pointer x is new int, right? Heap is global scope as much as you would like it to be. Like it can live for how long as you want it to. It's not really global scope. But okay, so this is literally what we did, right? We say, okay, int data is new int, right? Int pointer data is new int, and then here is some chunk of memory that's not ours, right? Right. So we say this, okay, and then we hit this, right? And what happens? The end of scope, right? This is the end of scope. Just remember the word scope. It's whenever you hit this, that's your end of scope, right? So we hit this, right? And then the compiler realizes, okay, well, you're not allowed to use x anymore, right? So x is basically out of our limits. We're not allowed to use this anymore. But this data, right? This is still in the heap, right? So this will stay here as long as it wants to, or until we tell it to stop existing, basically. So at the end of your scope, you're supposed to say, okay, well, I'm done with my data, delete x. And this is cleaning up after yourself, right? Does everybody get that? Because we're going really fast. We're covering a lot of topics in a very short amount of time. Right. So you say, okay, well, I want new data, right? I want a new integer somewhere located on the heap, right? Which is dynamic storage duration. It's somewhere here. We don't know where. It might be here, might be here, might be here, or maybe there, right? Let's just assume it's this one, right? So we say, okay, well, this is a pointer to here, right? And the thing with pointers is that they themselves get popped off the stack, but their data still exists, right? So when we reach this, we're no longer allowed to use x, right? That means that the only thing that we had to this data, right, our pointer to it, it's gone, right? So then if we don't delete it ourselves at the end of this block, then it's just gone, right? Yes, you have to allocate memory, not for every pointer. You can have a pointer to stack-based data. Yes, the value still exists on the heap. That's the very thing, right? Right. So we just have those 8 bytes, right? these 8 bytes and then these 4 bytes on the heap, right? So we use 12 bytes for 4 bytes of actual data, right? And then at the end here we say, okay, well, this one is no longer allowed to be used, so we need to get rid of the heap data. If you dereference it, this undefined behavior for a null pointer, like your program will crash. Let's just stick to that. You'll crash, basically. It should only be, never mind. You guys are responding to them in chat, so that's fine, right? So this is the heap, right? This is the heap, right? And this is the stack, and they work together, right? So the stack contains data about where everything is on the heap, and the heap contains the actual data. Because your stack is limited in size, and your heap can be however big you want it to be. If you have 64 gigabytes of memory, then go crazy. All right. Okay, so those were 2 storage duration types, right? You have automatic, you have dynamic, you have static, and you have thread local. And these 2 we'll talk about some other time. But we just had these 2, right? This is simulated in terms of the stack, and this is simulated in terms of the heap. And then we'll get to smart pointers as soon as someone covered structures. Also, that is invalid syntax. You need to have the star after the int. Yeah, but that's the wrong channel to ask me questions. Okay. That was it. The next lecture will most likely be from Yinse. He'll be talking about data structures and how you're supposed to clean up after yourself, basically, right? How you can do that without having to actually think about it very much. And yeah, this is called a memory leak if you don't delete this, because you'll lose memory. You can never access that again until your program terminates and Windows is smart enough to clean it up. Okay, that was it. I hope I wasn't going too fast or anything. I hope it was a nice experience. I hope I explained well. There was a lot of chatting going on. I hope I did well. Yeah. Okay. Glad to hear that. Okay, if there's any questions now, ask them. Yeah, look, Alex, we covered a lot of data, like a lot of, we covered a lot in 35 minutes. I want to give people time to process this, and then next week somewhere we get RAII and data structures. Yeah, I needed a break from linear algebra as well. Yeah, I am recording this, but I'm not sure whether we're going to upload this because this is a pretty messy lecture. They can't see what's going on Discord, etc. The next lecture will be 4 days, I guess. No, I'm not ready for tomorrow. Yinse is going to get the next one. Right? She will be giving the lecture. It's the bottom staff member. Yeah, probably 4 days. But it's going to be about data structures and resource acquisition is initialization. Yeah, not data structures like you would get on university now. Do you want to give the value 0 to the integer that you allocated? Or do you want to say, okay, this pointer is now a null pointer? No, it's not going to be talking about containers either. It'll be talking about like writing your own struct. Okay. Ask your question in beginner CPP month, and we'll help you out. I don't think you'll be doing vector. You'll be doing some more basic stuff. All right. Well, that was it. Thank you all for tuning in. Don't forget to claim the lecture role by typing ++ lectures or ++ lecture, whatever it was, and then you'll get the role, and you'll get pinged whenever there's new lectures or whatever. Yeah, sure. Yeah. This is our lecture. Artwork. We'll be giving lectures here during Corona times. You can buy me beer as gratitude. My renderer hasn't been worked on in 3 weeks. I set up unit tests and did nothing after. But yeah. Alright. Thank you guys for tuning in. No, I'm not doing 3D rendering. I was going to work on a UI project, right? But then I realized I hate doing graphics, and then you roasted the shit out of me for wanting to do batch rendering, right? So I decided to quit.